Oh, okay. So, hey. So, real talk though. Okay. So, Old Chicago. Old Chicago. You've heard of it. Okay. Now, so anyway, Old Chicago. They do this late night deal where after 10 p.m. you can go in and get all sorts of late night deals, or whatever. But one of them is just the best. Okay. It's like one of the best deals ever. I swear. So you can go in, get a personal pizza. Not huge, but personal pizza. Old Chicago's pretty good pizza, I would say, but it's normally a little pricier. But you get this personal pizza, one topping, $2. That's a steal, okay? So that was my college jam, and like I still do it from time to time, but it's pretty late now, so I'm usually trying not to go out that late. Okay, I did once over break to it, and so anyway, they're called pub pizzas, and so like people like would always go down there. So we had an old Chicago like really close to my college. It's like there would be like on any given night at least one table there for my college. Just people getting pizzas and basically that's all we did. And so like we go there and be like, hey, this is our fourth meal, like or if we like skip supper or something like that, we're like, hey, this is our meal night, just go and get pizzas. And so like, get a few pizzas or like, take some to go and just have them for lunch the next day or something like that. That was where yeah. So you can get like three pizzas for $6. Yeah. So like I would get like a pepperoni, a bacon, and like a sausage pizza. Just beef. Yeah, $6 plus tax and tip. So, but still, very reasonably priced for the amount of pizza you get. Yeah.
So you know, you say like, wait, I'm on it, like I'm on it. Is that a verb?
Yeah. I mean, I did. That's what you say. I mom Coles. Mom is the verb. Past tense, of course. Hey. Okay, focus back up here. Focus back up here, please. Awesome. Okay. So yesterday, 2 days ago, how far did we get through these notes?
I have no idea.
You just started.
Yeah, you got to the second page.
We got through the triangle proportionality theorem. We said, hey, if we have a line parallel to a side of a triangle that intersects the other two sides, then it divides the sides proportionally. We did those proportions. And then we went through A.
Yeah.
Okay, so
We're on B.
Okay, we're on B.
We're not.
Oh, yeah, so
Next
B
page.
right before the last one.
No,
Oh, we didn't B on over
You
here.
just read half and start B.
Yeah, we did.
No, we didn't.
Okay. Right here.
We didn't start B.
Right here.
We
It's up.
did not start B.
Yeah.
Okay, so we went through and we said, hey, if we have the original triangle proportionality theorem, it was an if then statement. We can do the converse of that, flipping the order of hypothesis and conclusion, and say, hey, if a line divides the sides of a triangle proportionally, then it will be parallel to the third side. We went through this first one. We said that was true because this is proportional, so these lines were going to be parallel. Now we can also try that on this one. A student states that segment UV must be parallel to segment ST. Do you agree? Why or why not? This one's a little bit different than our last one. Our last one, we had measurements for all these, so we set up a proportion. We said like 42 over 21, is it equal to 30 over 15? And said, oh yeah, 2 equals 2, so yeah, they are parallel. But on this one, we have to go about it a bit differently. How would we go about this one since we don't have any side measurements? What do we know about these triangles? Noah.
We know on like RU and US are cut perfectly because they're both similar.
Okay, so they are congruent. So we know these are congruent, so we know U is kind of the midpoint of this. And what else do we know about this triangle?
The RV and VT are also congruent to each other.
RV and VT are also congruent to each other. So do we know the measurement of RU? What can we call it? We can call it a bunch of different things. I would stay away from calling it a number, just because that can keep us attached to the number, but you can make it work. Okay, it would work still. But I just try to stay away from calling it a number, because X tells us that it can work with any number. So if RU is X, what else do we know? US is X, because it's also the same measure. It's congruent. Okay, what can we do over on this right side?
Y.
Call them Y, right? Call RV Y and then call VT Y. We can call them any variables, right? We can call question mark, smiley face. We can make one smiley face, one frowny face, You can make one a smiley face without a nose, one a smiley face with a nose. That kind of stuff. It could work. You just have to be very careful with your nose. Okay, a star and an asterisk, This is Make one Mr. Tice, one Mr. Castle. So one talk like really quickly all the time, one talk really quickly half the time. So.
One only talks really quickly after somebody's used.
Truth. Okay, so if we were to have this set up, how would we set up our proportion here to test whether or not the proportions are equal and to see whether or not these lines are going to be parallel? Ian?
You put x over x, y over y.
Yeah, I think that would work. Okay, if here we put 42 over 21, that'd be the same thing as x over x, right? Part of this side over the other part of the side, like the top part of the side over the bottom part of the side, and here y over y would be like the top part of the side over the bottom part of the side. But we're wondering if x over x will equal y over y. How did we do this before? We had a couple options. We could cross multiply and we could simplify, right? Okay, we want to look to simplify maybe. What would x divided by x be? 1. What is anything divided by itself? 1. What if you have 200 pizzas, 200 single topping pub pizzas at Old Chicago, and you had 200 people? How many pizzas does each person get? 1. Okay, it doesn't matter what the number is. Anything divided by itself will be 1. So x, an arbitrary number, divided by itself is 1. So this ends up being 1. What does y over y equal? 1. Does 1 equal 1? Are these lines going to be parallel? Yeah. So, do we agree with the statement? Yes, we do agree. So, did we actually technically need to put x and y here? No, but it really helped us kind of discover that that was true. If we hadn't put that there, we probably wouldn't have gotten to those steps as easily, at least. So, putting it there helps us discover, hey, if these are the same length, then they're going to be proportional. If these are the same length, then it's going to work out. Make sense? Thank you. Go to the back, please. This back page is very, very similar to actually what we did in 4.6. You guys recall 4.6 is very similar to that with a lot of the problems we had with those sides. So finding an unknown height. We're going to call this method we're going to do, we're going to call it indirect measurement. We're going to call it indirect measurement. Now with indirect, what's that kind of the opposite of? If it was direct. So like if you were to directly measure something, that would be like me taking this meter stick or yardstick over here, depending on which one I grab first. Yardstick it was. So if I grab this yardstick and say, okay, this desk has a length of, about 24 3/8 inches. Okay? So that would be, good? Okay. So that would be like my, I explained it. Mr. Carlson.
That was like the most delayed.
So
That was really delayed.
That was super delayed.
that would be directly measuring it. Now indirectly is going to be, we're going to use properties of similar triangles to measure heights or distances. That might be difficult to measure directly for a variety of reasons, whether it's too great, too big of a distance, or maybe it's unavailable for you to get all the way up there, that kind of thing. So, we're going to go through this example and talk about it. And really all this math is stuff that we've actually done already. So, first, example 1 here. In order to find the height of a palm tree, we have a palm tree here. My parents love palm trees. They go bananas. I'll tell you. You measure the tree's shadow. And at the same time of day, you measure the shadow cast by a meter stick, in this case a yardstick, that you hold at a right angle to the ground. Why would you hold this at a right angle to the ground? Okay, to make a right triangle. But why does it have to, you can make a triangle if it's not a right angle.
So like the shadow is.
So it's like the tree. The tree's going to be at a right angle, right? Like with the way it stands at the top, generically speaking, assuming we pick the right kind of tree, to where it's straight up and down, it's going to be forming a right angle with the ground. So the center of the tree is going to be forming a right angle with the ground. So that's why we would do that. So that's the only reason why it's a right angle here. So, but you have to do it at the same time. Why would we have to do it at the same time of day? The Earth moves, okay? Our sun's gonna set on us. Our Earth really moves, but we call it the sun setting. Okay, we pretend the sun moves even though we're the ones moving weird, right? Okay, anyway. So the sun will set, the Earth will move, so the daylight, the shadows will shift, right? As different times of the day, shadows are different lengths and they're in different spots. So we'd have to do it at the same time of day for this to be true. But if we do this, we'll form similar triangles because of the way the angles work out. On these, the nice thing is we don't have to prove that they're similar. We're already saying they're going to be similar. So saying that these are similar triangles, okay, so saying these are similar triangles, we can figure out the height of this palm tree. How would we figure out the height of the palm tree if we already state that they're similar triangles? Ian.
Well, first off, you would do 1.6 over 7.2, and then 1 over x.
And what are we going to do with these two?
Don't you cross multiply?
They'll be equal, and then we'll have to cross multiply. So let's look at the setup right here real quick. So we did the bottom side of the small triangle over the bottom side of the big triangle, right? We did corresponding sides of the small over big triangle equals corresponding sides of the small over big triangle. 1 over this x here. My pen's not very calibrated, and I'm not left-handed, so
I know.
So-
I'm nice to meet you.
So, how would we solve this now? Someone said we cross multiply. We can solve for x. So we could have 1.6x is equal to 7.2. How do we solve for x?
You divide 1.6.
Divide both sides by 1.6. You guys remember this notation? This is the same thing as writing 1.6 over here and here. We divide the whole thing by that same really thing. Okay? So x is equal to 4.5. It does end up equaling 4.5. Now it might be hard to figure out without a calculator, right? We can do the math. We know how, but it might be a little difficult. And it would definitely be easier with a calculator, right? 4.5 what? What meters? Meters. We're not talking about ostriches. We're not talking about, like zebras, something like that. We're talking about 4.5 meters. Okay, so this tree is going to be 4.5 meters tall, or approximately 15 feet around. Yeah, it's a pretty decent approximation. Questions on that? Is this any new math? No, it's not. Okay. I looked at Tyler and he's just like profusely shaking his head. No, it's not new. We've done this. Okay. So he didn't actually say those things, but he was just profusely shaking his head. I added all of them. Okay, let's go to the next example here. I want you to try this one, but first let's talk about it. So Sid is 72 inches tall, like Sid the Sloth, right? To measure a flagpole, okay, so real talk, okay, you know Sid the Sloth from Ice Age, okay? So, what?
Dang.
He is
He
pretty
is
big, okay?
pretty awesome.
So, the church I go to, the former pastor there, reminds me so much of Sid the Sloth. Pastor Steve Molmeyer.
Oh, Steve kind of does.
Right? Right? Okay, the first time I went to this church, I went with a friend, and he's just like, he's sitting there, he's like, Sid the Sloth. I'm like, oh my gosh! Okay, so anyway, Sid is 72 inches tall. That's, how many feet, guys? 6 feet, exactly, okay? To measure a flagpole, Sid stands near the flag. Flagpole like we have out in the parking lot over on that side of the school, right? Sid's friend Miranda measures the length of Sid's shadow and the flagpole shadow. I want to talk about why these are similar triangles, actually, by the way. These are right angles, with the person standing to the ground and the flagpole to the ground are both going to be right angles, right? The shadow that casts from the sun, is the shadow going to be hitting, is the sun going to be hitting us at the same angle? Yes, it will be. Actually, it will be hitting us at the same angle.
portion as the sky, they're both right angles.
So it's going to be hitting us from the same angle, and thus these triangles will be similar by angle-angle similarity. What?
Big flat.
Yours is not similar.
Okay. It would be, as long as we're close to each other. Okay, so as long as we're not like miles apart or more, the sun would be hitting us by such a minute difference in angle to where it would be imperceivable. Is that fair? use
small
use
difference.
big
Don't-
words. You prove yourself right. You know. No, but
That's
But it would be-
fragilistic
yes.
calculations.
okay. Just name drop it in there. So that's why they'd be similar in this scenario. Okay. So as long as you're standing close to the flagpole or close to the palm tree or close to the Empire State Building or whatever, this would work that way. Okay. So I want you guys to find the height of the flagpole. Go ahead. Cool. Do stuff, math students. And also,
I did Thursday another big one.
Okay.
It's called math.
Did you hear one of the big words I said?
Something big.
I did not say that word.
You got it.
I mean, that's what I heard.
That was Evan. That was
I
Big
didn't know
News
how to
Killer.
pronounce it.
You were led astray. Yep.
Oh, we don't actually have to know, but.
Did I get it right?
Oh,
Do you want it in feet too?
I don't know.
Did you? Yeah, I think so.
Yeah, I got it. There you go.
There you go. Looks good to me. Hey,
Can you stop?
was that? Hey, that's class. My bad.
Identity theft is not good.
You know the family stuff for a year. Michael.
102
Till Monday.
inches.
Don't do it. Don't let them.
Hey, on Monday, we are math testing. Read your last sentence.
Ah!